All right, welcome class. And today's lesson is going to be really short. Basically, we're just dealing with identifying chemical reactions. And it's really simple. Basically, there's four major types of reactions that we're going to deal with and identify in class. And you just have to be able to recognize and distinguish one chemical reaction from another. The other day we dealt with chemical equations, and that's what, from now on, when we refer to a chemical reaction, that's what we will be taking a look at, is chemical equations. And so when we have a chemical equation, which we said is basically like a recipe for a chemical reaction, it tells us, how much to put in, it tells us what the substances are. And so that's part of what a chemical equation does. We also talked about balancing chemical equations. So today we're going to take a look at identifying types of chemical reactions. And there are four, and they're pretty simple and basic. So let's take a look at the first one. The first one here is what we call a synthesis, or sometimes it's called a composition. So it kind of depends on the what you're referring to here. The definition is these are reactions in which you have two or more elements or compounds combining together to produce a bigger one. And so if you take a look here, for example, you have on the reactant side, you have hydrogen and oxygen, two separate elements, and they're going to combine together. That's why there's a plus sign there. And then over here, you have on the product side, you have those two joined together as a compound now. And so that would be they've composed into a compound, or they've synthesized is maybe a better word, into a compound. And that's all that a composition reaction is you have two or more things. It can be three or four things over here. They don't always have to be elements. Sometimes they can be compounds. So you might even have compounds that form into a bigger compound on this side. And so that's what you're looking for in a composition or a synthesis reaction, is you have two or three or four things over here, and they're combining together to form one big compound over here. This one's a fairly simple one. You have hydrogen and oxygen combining together to form water over here. So that's not very complex. The next one here, as I take a look, is a decomposition reaction. And a decomposition is kind of the opposite of what a composition. So if a composition or synthesis reaction is one where you're combining things together to make one big thing, here you're starting with one big compound, and it breaks apart into either smaller compounds or individual elements. And this is a good example of that. Here you have a big compound with sodium chlorate here, and it's breaking down into sodium chloride and oxygen, and so you see that it's decomposing or breaking apart. And that's kind of a good way to remember it. If you think of decomposing, if you think of a dead body, decomposing, what is it doing? It's breaking down. Okay, it's breaking apart into smaller bits and pieces. If you think of a leaf as it decomposes, what does it do? It goes from the one whole big leaf into all the little small parts that, if you step on it, it breaks apart, as it dries out and decomposes. That's the idea here, is you have one big compound and it's breaking down into smaller compounds. That's what a decomposition reaction is. These are probably the easiest to identify. Now, a lot of times with decomposition reactions, they're actually moving to some extent against the natural order of things. Not always, but with a lot of decomposition reactions, that's the case, because what you have over here in your reactants is actually usually a very stable compound. So in order to cause it to break down and to break those bonds, you actually a lot of times have to add energy to it. So a lot of times what you'll see over the arrow right here is you'll see what looks like a triangle. It's actually the Greek letter delta, and I'll draw that for you guys tomorrow in class. And that simply means that you add heat to the reaction. And so a lot of times you have to add heat to the reaction in order to break those bonds and separate the components of that compound. So that would be another type of reaction. The third type of reaction is what's called a single replacement reaction. And a single replacement reaction is exactly what we have here on the screen. It's a reaction in which a more reactive element, and more often than not this is usually a metal, the halogens can kind of do this as well, and it replaces another element, a less reactive element. So for example here, you have titanium is our metal here, and it's originally bonded to chlorine. And it's a stable bond, everything's good. But over here you have a free sodium atom, or several of them. And sodium is much more reactive than titanium is. And so when you get in a situation like this where you have a metal or an element that is much more reactive than what this is currently bonded to, basically this metal here is going to come over here and kick out titanium. And if you notice on the product side, sodium is now bonded with chlorine and titanium is now by itself. So basically what's happened is titanium got booted out by sodium and sodium replaced it in that bond. And part of the reasoning behind that is simply because sodium is so much more reactive. More energy will be lost in the process of forming sodium chloride, and atoms are always looking to lose more energy. So if they can, even though this is a stable bond here with titanium and chlorine, and it's lost some energy, if I can lose even more by bonding with sodium, then it's going to do that. And so that's how that works right there. So that would be what we call a single replacement. And the reason we call it single replacement is because one thing is being replaced. In this case, it's titanium was being replaced by sodium. Later, in another presentation, we're going to learn how to predict single replacement reactions, whether or not they can occur. And so for example, this one, just because I can write it and draw it here doesn't actually mean it can happen. So just because I'm drawing it up as sodium replacing titanium does not mean it will actually be able to happen. One of the things that we'll find out has to be true is whichever metal is replacing the other metal, it has to be more reactive. Otherwise, just because I can draw it up here on the board doesn't mean it will actually work. All right, let's move on to our last one, and then we'll be done. Our last one is a double replacement reaction, and this one's probably, as you look, it's the biggest of the equations that we're looking at. And you have, this is always ionic bonds here. You'll always have two compounds, so you have sodium chloride and you have sulfuric acid here. And what basically is going to happen is the first element in each compound, so that would be sodium here, and that would be hydrogen here, they're going to kind of swap places. So that it's kind of a double swap. So hydrogen's going to come over here, replace sodium. Sodium's going to come over here and replace hydrogen. So that's basically how that's going to work. And if you look over on the product side, that's exactly what happened. This sodium here that was bonded to chlorine, it came over here. It's now bonded to sulfate. This hydrogen here that was bonded to sulfate came over and replaced the sodium, and you ended up with hydrochloric acid, or HCl. And you have hydrogen bonded to chlorine. And so they kind of swapped places. So you had a dual swap there. Hydrogen swapped where sodium was, and sodium swapped where hydrogen was. So that's what we call a double replacement reaction. And so those are our four types of reactions, and that's how you identify them, and that's what's going on. We'll practice some of this in class, and I will see you tomorrow.